Welcome to the Geometry Final Review. This is Standard 9. This is the second part. We're going to do the problems in this part, and I want to make a few little things that I've noticed. First, I'm going to put my key here for a moment. This shape right here, just so you'll know, goes with this problem right here. It doesn't go with the first part A. It only goes with 1B. So this is the 1B shape. Just keep that in mind, and as we're going through. Got to go through these kind of fast. And so let's go ahead and put just a sheet up here so we can do 1A. In 1A, they tell us that they have a circle that has a circumference of 20 pi, and they want to know what the area is. So let's put our formula here. Circumference equals 2 pi times the radius, and the area equals pi times the radius squared. Now, okay, there we go, back in focus. So I want you to think for a moment that we don't really have a way to go directly from circumference to area. But both of these formulas have something in common. They both use the radius. So I'm going to use this to get to a radius. So basically I'm going to go from circumference, I'm going to find a radius, and from the radius I'm going to find the area. Okay, so it tells us that the circumference is 20 pi, and I know that the circumference equals 2 times pi times the radius. I'm going to use a little bit of algebra here real quick. I'm going to divide both sides of this by what I want to get the r by itself, so I'm going to divide both sides by 2 and by pi. Something nice is going to happen. That's going to disappear. That's going to, well, turn into 1. Those pi's will go away, and 20 divided by 2 is just 10. So 10 is the radius. Now that I have the radius, I can just plug it in. Area, so I went here, now I'm going up here. Area equals pi times 10 squared. Okay, they asked us to leave our answer in pi notation, so we're just going to do everything but the pi, 100 times pi. So our answer will be 100 pi. Okay, very good. Now, let's look at the next one. And I've already kind of used some properties here to solve this. And what I've done is I've used what I know about squares and what I know about circles. Well, this diameter is going to be the same as the side of the square. So I basically said, well, this radius must be half of the diameter, or half of the side of the square, so it equals 6. And I just plugged in my value, and I got that the area of the center part of the shape is 36 pi. Now, they asked us to find the shaded area, and this is a donut hole problem. So I need to find the area of the square. So the area of the square is going to equal the sides squared, or the length times the width, whichever you prefer, but 12 times 12. So the area of the square is 144. Now, if I want to find the shaded area, I need to take the area of the square and pull out the area of the circle. So I'm going to do 144, and I'm going to subtract the 36 pi. Now, they asked me to leave it in that form. So that's how it would look. That's going to be the measurement, the unit that they're using here is all centimeters squared. If I do put it in the calculator, I should get, according to the key, 30.9 centimeters squared. So there's how to do that one. Okay, lots of circle stuff going on here. Okay, next one, problem 2. Okay, in problem 2, I'm going to basically use what I know about all the rules that I can think of about circles. Let's put in what we do know. CD, right here, tells me that that is 6. That's right there. Well, what is this? This is a diameter, so I know that AC is also 6 because they're both radiuses of the same circle. Now, I can use the Pythagorean theorem to find AE, and I think I'm going to do that because my ultimate goal is to find AB. But for right now, I'm just going to find AE. So let's see what that is. AE will be, we'll just use the letter X for it right now. X squared plus 3 squared should equal 6 squared. Let's see, that's 9, that's 36. Subtract 9. I'm going to get x squared should equal 27. And so, if I take it one more step, x is going to equal the square root of 27. So x equals the square root of 27. Leave it at that. So let's put it up here. This is the square root of 27. Now, I see similar triangles. If I think of drawing a line parallel to this, like this, perpendicular also, I'm going to have two kinds of triangles that I can do. This side, let's see what we can do here. This side altogether is 12. Let's see. So 6 is to 3. So I'm doing this side as to that side. That's one of the things we did with similar triangles. As 12 is to y is what I'll call it. So in other words, this is to this as this big piece is to that little piece there. Cross multiply, I get 36 equals 6y. I divide by 6. Y equals 6. So it looks like this one is going to be 6. Now, I could use the Pythagorean theorem again. I know that this whole long side here, AB squared plus 6 squared should equal, what is that? 12. Or 36 and 144. Subtract 36. And we get 108. And so AB quantity squared equals that. So AB will equal the square root of 108. Now, I could also look at it this way. I'm doubling. I can see my scale factor now. 6 goes to 12, 3 goes to 6, and so this can also be, should give me the answer of 2 times the square root of 27. Let's look here for a moment. I'm going to look for a calculator real quick. Hope I can find one. Does not look like it, so I'm just going to have to try it this way. That one doesn't work. Oh, it does. So I don't know if you can see that or not. But the square root, oh, this was one of those. The square root of 108 is about 10.39. And 2, let's see, clear. The square root of 27 times 2 is also about 10.39. So a couple of different ways, get the same answer. So AB is about 10.39, and I'm a good student, so I circled my answer so you could see it. Okay, now, hope we have time for this. The next one, problem 3, is going to I'm just going to put it in in a part 3.